Welcome everyone to today's ABU Online for Design Professionals. Today's topic is part 2 of the Advanced AB Walls tutorial. My name is Jeremy Zeiss. I'm one of the engineers here. And throughout today's presentation, feel free to go ahead and write any questions you have inside of the question box of your meeting, and Nate from our office will be answering them when they come up. But I do want to thank you guys for taking the time to go through this webinar. Anytime we get a chance to learn about more tools that can help make your retaining wall design more efficient is always going to be more helpful. And these advanced features are something we don't cover in our typical tutorial, so you might learn something new here. But that does bring up the point that if you have not gone through a standard tutorial of ours to learn how to use AB walls to design a wall, I would encourage you guys to call in or email into the engineering department here at Allen Block to get one of those scheduled. We do one-on-one free tutorials that take about an hour, and throughout that tutorial we'll take you through a sample project to get you started on learning how to take a wall from start to finish in terms of design with AB walls. But getting started here, like I said, this is part 2 of the advanced tutorial. So I'm going to work through a model that we already have designed. You can see we've got all of our pages filled out. We've got our elevation, our plan, our panel, and our sections page all designed already. So what we're going to do is just talk about some of the advanced features today. And getting started with that, we're actually going to talk about advanced controls on the software. So you'll notice on our elevation page, we're going to start here. One thing that you may have noticed if you've used AB walls is if you need to come back here and enter in a new station in between these points, it can be quite difficult. The only apparent way to do it as it is right now is to shift over all the boxes and type all the information in again, leaving an empty box for you to add your point. But with advanced features, we're actually able to add a point in between two existing points. So the example I'm going to run through today, we're going to imagine that we have to add a point that steps down a course on the top of the wall and steps down a course on the bottom of a wall in between stations 2 and 3. And to do that, what we do is come to the Advanced tab at the top here. We're going to go to Elevation Stations and click Editing Controls. And what that's going to do is make these boxes visible down here in the bottom right-hand corner. The first one, which is similar to all of the pages that we'll go through, has the option to change the graph spacing in the background. Our graphs have grids that are 5 vertical blocks tall and 10 horizontal blocks wide. That's kind of the measurement here. So we don't have to worry too much about that. But one thing you'll see is that here we have an Add Station button. So if we need to add a station between 2 and 3, all we have to do is click Add Station. It'll ask what number we would like to add the station after. And since we're going in between 2 and 3, I'm going to type in 2 and click OK. Now that added a station that basically copies the station that it took its place. And what we want to do then is make sure we change the station right away. We're going to say it's in between the two, so we'll say it's at about 105 feet for the station. Now, we did also say that it's going to step down a course on the top of wall and on the bottom of wall. And while I could type in the elevation for that, what I can do instead is go ahead and we're working in station 3. I can move up my station number to 3, and I can say my top of wall needs to come down 1 course. Okay, so you see now our station 3 steps down a course, and then we want our bottom of wall to also step down a course. So I'm going to go ahead and click down on the bottom of wall, and you can see that dropped down our bottom of wall. Now, what I can make sure to do here then is, like I said, we want to make sure we go ahead and change our station, and then we're going to go ahead and click Draw Elevation. So I go ahead and click Draw Elevation, and you can see it added a point where our bottom of wall drops down, and our top of wall also drops down 1 course. Now, if we came back to this and said we needed to delete station 3, what I can go ahead and do is come here, click delete station, and just type in 3 and click OK. So you can see what that did is all it did is take that point out, and we don't have to worry about it anymore. Now, the next thing we're going to do is move on to our plan view. And on our plan page, what we're going to do is also hit this advanced plan editing controls. And you can see we've got the same graph spacing, but then what we also have is the ability to change chord length between our different station numbers. We're not going to mess with that in this model because it can be tricky to fix if I change it. But basically, all you do is say between stations 0 and 1, you could increase your chord length. Between stations 2 and 3, you could change your chord length, and so on. But I'm not going to worry too much about that. But also, you can add stations and delete stations just like you could in the elevation page. So now we're going to jump over to the panel page, and this one is pretty interesting. What we can do is go to Advanced, down to Elevation Panels, click Editing Controls, and in Editing Controls, we can basically click Edit Panel. We can say we want to edit Panel 2, and what we could do is actually increase the panel location, so changing where that panel takes place. I'm not going to do anything there, but you would just click Edit Panel, and then it would fix it. Now, that takes us through the advanced controls inside of these few pages of ABU Walls. Now we're going to get into a few of the advanced features of our section page. So starting off, what we're going to talk about is this Design Parameters button. There's a few things we're going to touch in here. One, you'll see that our soil description, no, actually, we'll save that for later, but we will talk about seismic right here at the start. Now, seismic is something that is very important to include in your design, especially if you're in a location that is affected by seismic parameters, or if there are lots of earthquakes in your area. So lots of West Coast in the United States and Canada, this will be very important. And oftentimes, if you do have seismic in your area, that will drive the design. So you can see in our software, we ask for horizontal peak ground acceleration, and that number is something that we can either get from our geotechnical report on the project, or if for some reason that's not available there, we can go to the USGS website, type in our latitude and longitude of the project, and then we can actually get a value back for horizontal peak ground acceleration. One number that we see commonly used, just as a default, is 0.3. We'll go ahead and keep that, and then we would click Hide to apply it to our section. Now, if I calculate, you'll see now we're doing everything based on seismic. So seismic is highlighted here. I can switch between static and seismic. You'll notice my static factors of safety are much higher than my seismic factors of safety. So now, if we're designing with seismic and I decide to add a slope, or my wall calls for a slope above, I can come here and go ahead and type in the slope. We're going to say we have a pretty steep slope, a 2-to-1 slope. So when I go ahead and click 2-to-1 and go ahead and click Calculate, I'm going to get a pop-up that says, you're attempting to design a wall with a slope above that exceeds the maximum unreinforced slope allowed. And The reason that we get this message is because we use by default the MO method, or the Mononobe-Okobe method of understanding seismic conditions. So what that means is that when we use the MO method, it's going to take the slope we inputted and it's going to basically shrink that slope until we meet our factors of safety. So in this situation, if I were to click this, you'll see that my slope actually softened down to a 2.37 to 1 slope. So it's gotten slightly less steep. Now, that's the way that the MO method works. If I come back in here and type in 2 again, and then click calculate again, we get the same box. And I click trial wedge. Now, trial wedge is a different methodology used for solving the seismic issues here. And basically what it's doing is, instead of moving our slope down or making our slope less steep until we hit our factors of safety, it's going to keep the slope how it is, and instead we're going to fix the stability of this wall by adding reinforcement to our slope. So if we know we need to have a 2 to 1 slope above, we can keep that in there as long as we reinforce the slope. It's also worth noting that in these situations, it is going to be necessary to run a global stability analysis on the slope as well as the wall structure, but you guys should know that AB Walls is not capable of running global stability. We actually export out to a different global stability software. But when I come in here and say trial wedge, I encourage you guys to read this if you aren't familiar with what it is, but we go ahead and click hide, and you can see we keep our 2 to 1 slope here. Our grid's extended quite a bit, and it says slope should be reinforced. Now, one way to introduce reinforcement into the slope is we can go ahead and click calculate internal compound stability, and it's going to quick tell us that no, internal compound stability is not the same as global stability. And so we go ahead and click OK, and then it's going to ask us if we want to add grid to the slope, and our answer for this is going to be yes. So we go ahead and click yes. We get this little menu here that says starting height of your first grid in slope. We're going to say 0.667. That's about a block height above the top block. Our spacing between grids in the slope, we'll go ahead and keep that. That's going to be about 2 courses. Number of grids in slope, we're going to say we have 3 grids. And then we also have grid length for the grids in slope. Now, we don't want 4 foot of grid in our slope. We want to potentially match the rest of our wall. So we'll go ahead and say 20 feet for the length on that grid. Now, we go ahead and click calculate internal compound stability. It's going to take a little time to load, and then you can see we've got our slip planes that run from the earth behind the wall into the wall. You can see now we meet our factors of safety, our sliding, overturning, all of this information here meets our factors of safety. So that's how to do seismic design inside of our sections. Now, the next thing we can do is, say you're designing with different methodologies, or you do quite a bit of work that uses different methodologies for design. What you can do is come into this wall settings option and go ahead and come to this menu. So we're going to go ahead and click on bearing capacity, and you can see we've got a few options. So the AB modified Meyerhof method of designing for bearing capacity is different than the NCMA's. Our modified method only uses the footing in order to run bearing capacity calculations, but NCMA's uses the full infill zone of the soil. So you can switch between those if you want to. Wall rock will allow us to basically change the minimum amount of wall rock in our wall. We'll touch back with that in a little bit. Our dynamic active earth pressure, You can see we've got both AASHTO and NCMA's methodologies put into our software, and how it's defaulted out is to choose the greater of the two. But if you have only one that you're trying to meet specifications for or meet the requirements for, we encourage you to select that option then. Grouted connection, so those situations where you've got a fence above the wall and you need to grout into the wall, you can make that editable or not. On this tab, our block interaction tab, so if you guys have designed with other design softwares, you know that oftentimes you need different vendor data files, so files that talk about our interactions between our block specifically and different geogrids. But our software actually has that all embedded into it with all of the Allen Block products, with all of the grids that we have listed in there. And so we don't actually give the option to change these values because these have been chosen based on testing that we've done. So we do know that they're right. But what you may find you need to do in certain circumstances is actually add a reduction factor into these block shear test results or the grid connection results. So, for example, if you've got a situation, we had one where a wall spread out their classic blocks, so they were about 4 or 5 inches apart, so that they could plant plants in between the blocks and the cores of the course below. So that would have a design reduction factor to it. Now we've also got our unit weights. So here you can go ahead and come in here and change the unit weights of your concrete. You can change the weight of your wall rock and also the weight of your no fines concrete. And the reason that we have that in here is just because, every area uses different materials to create concrete or to make their no fines concrete, anything like that. So it's important to make sure that this value is correct for your location or what your guys' mix consists of, just to make sure that you're designing using the correct weights for your concretes and wall rocks. And then lastly, we've got our minimum geogrid length. Our software is defaulted out to 4 feet. 4 feet is the minimum grid length for commercial projects. If you're ever on a residential project that has limited space behind the wall, you are allowed to switch our minimum grid length to 3 feet if you need to. But that takes us through the wall settings tab. What we'll quick do is go back to this wall rock just so I can show it. You can see you have the option to fill the entire infill area with wall rock. This would be for like a water application or something like that, where the high water elevation reaches somewhere near the top of the wall. But you can also use this just to make the whole wall have a continuous amount of wall rock behind the top blocks, or behind all of the blocks. You can come in here, and if we were to go ahead and choose 2 feet, click hide, come back here, and inside of our model, we go ahead and click calculate. And now you can see we've got 2 feet of that wall rock there. I'm going to go ahead and take out our slope, as well as our seismic, just for the purposes of this tutorial. And I'm going to move our grid back down to 4 feet. So you can see we've got that 2 feet of wall rock behind the back of our block. I can go ahead and change that by clicking on the design parameters. Oops, never mind. By going into wall settings, coming down to wall rock, and going back to our variable depth. But we're going to change this to 1. Hide, calculate again. Sometimes you have to do it twice. Okay. It's not showing. We'll just go ahead and go into continuous 1 foot. Okay, so now we've got our 1 foot of wall rock behind the wall again. Now, the next thing we'll quickly talk about is how to handle terrace walls inside of AB Walls 3D. And one thing to note about terraced applications or terrace walls is that lots of times they're misunderstood. People think that if they design multiple terrace walls instead of one larger wall, they can avoid having to do the engineering required for that taller wall or that whole structure. But what we actually say is if you're going to use AB walls to design a terrace wall or a terrace application, we want to make sure that if that top wall is within 2 times the height of the lower wall from the back of it, then it's going to have an impact on the wall below. So, for example, you can imagine where if we had another 6-foot wall behind this, 5 feet behind this wall, so that it's a total structure height of about 12 feet, and we've got a terrace application. This taller wall or the top wall, as long as it's within 2 times the height of the lower wall back from the lower wall, it will have an impact on this lower section. And what that means is that we need to design the lower wall as if it is basically a portion of the total wall structure. So you guys know best practices always says that retaining walls should have 60% geogrid length compared to their wall height. Now, that's what's going to happen here. So if we have 2 6-foot wall, so a 12-foot wall, we need to make sure that our grids for our lower wall extend to be 60% of that total structure height. So we're going to say our minimum grid length is at 8 feet here. Go ahead and click calculate. And we've hit that 60% of our total structure height if this were the lower wall on a 12-foot structure. Now, the other thing that we have to note in our design is that when that wall is impacting 5 feet back, that's going to act as a surcharge on this wall. So what we need to do is find out how much of a surcharge that actually is. And how we do that is basically we say, what is the weight of our soil? And we multiply it by the height of our wall above. So we said our wall above is 6 feet tall, and the soil weight is at 120 pounds per square foot, or pounds per cubic foot. So we go ahead and multiply 120 by 6, and we get 720. So now 720 gets put in our surcharge box, and then our distance from toe, we said it's about 5 feet from the back of the front wall. So go ahead and type in 5 feet. It'll be a dead load. Well, so dead load. Then we go ahead and click calculate, and you can see we've got our wall above acting as a surcharge on our lower wall. So you can see it did impact our design. We actually extended this top grid, so that's important to note as well. Now, that takes us through most of the advanced features inside of the section page. What we will start getting into now is actually some of the ways that you can customize your outputs from AB Walls. So some of the things we can do here, you guys all know if you go to File, Print, it's going to count our page numbers. We get a print box, dialog box. You can see if we have everything we want selected. We go ahead and click refresh page count. Go ahead and click print selected. Our file loads, and you can see we've got our full wall output with our plan view, our panel views, our cross sections, and all of our internal and external calculations. And then, of course, we've got that estimate at the end as well. But one thing you'll notice about all these pages is they've got a preliminary not for construction stamp at the bottom. Now, what we want to do in those situations is when you guys are designing walls, you don't necessarily want that preliminary not for construction stamp down there. If you're trying to sign off on a wall and stamp it as a professional engineer, then what you would need to do is we can go ahead and close out of this, and we can go ahead and go to File, AB Walls Options, and we want to uncheck Preliminary Stamp. We also want to click Print Company Logo and Print Company Information. What that means is we're going to go to Company Logo, and it's going to ask us to find a path to a file. So that file is going to be the image of the company logo you have. I am going to just choose a random image that I have on my computer. We'll choose the first one I find. I don't know what this is. It'll be a surprise. But then, so I've got my image here, and then I'm going to click, oops, I'm going to hide that. I'm going to go back to File, or Print Pages back here. I'm going to click Add Engineer License Information. I can go ahead and enter in my signature, my engineer name, any of that here. I can also save that information as a default here, but I want to make sure this Show Signature block is selected. I'm going to click Hide, and I'm going to refresh page counts and click Print Selected. Now it's just loading. And you can see, I don't know what image it added, but it adds our image, which would be our company logo in the top here. It adds our company information that we had selected. And then we've got our signature block here as well. So you can see how valuable this is. You can just easily import your company logo and company information right on here. So they have all of your contact information and your logo as well. But just super easy to do. So I'm going to go ahead and close out of this. Actually, one thing we'll note here is if you see on one of these pages, it says our soil information, and we've got our soil type. So it says well compacted silty sandy clay. We've also got all of these specifications in here as well. Maybe we don't want to have all of these points in here, or maybe not all of them apply. So we can actually go into AB Walls and go to Notes, and we can modify those notes. So we can change the type of soil we have. Into whatever we want. We can change our construction notes, what's included. So we just check the ones that we want. Same with surface drainage, and then we can add some default notes in there if we want, change it up if we need to. Inside of notes, we can also change specifications and modify what shows up in the specifications page. We can really just make sure that it's actually choosing what we want in there as well. Same with GeoGrid specifications and water management. Can go ahead and hide this, and basically we will now move on to our DXF export. So a while ago, one of the newest features we had for AB walls was actually to include this DXF export so that our engineers and designers could export our wall into AutoCAD. And being able to export into AutoCAD made it so that you could take your design that you designed in AB walls and basically put the drawing into your own submittal packages that you send out into your own documents to get signed. And this is just a really easy and convenient way to make sure that that drawing is accurate to what you designed. This was a big feature. It took a lot of dedication and effort to create, but it was one of our most prized features of AB walls. It made it so easy so that our engineers didn't have to draft all of their walls after the fact, after they had them designed. They could just pull them, copy and paste them from our own DXF export into their own AutoCAD as well. So I'm going to show a quick example of that. If you go to the File option, the DXF Reset and 3D Export option, you can come in here and actually click what you want to include. And once you have it all chosen, you go ahead and click Export to DXF. And what that's going to do is ask you for a spot to save your DXF. I'm just going to call it DXF4. Click Save, and it's going to say Complete. Now I can go into my File Explorer. I can go into Documents and open DXF4. So you guys will be able to see what it looks like in here. So right off the bat, you can see one of our sections. So it's got all of our cross sections drawn at a 1-to-1 scale. You can see we've also got our plan view here. You can see where we extended our grids as well. And then you can see our full panel view with grid locations shown in red. And then you can see our different sections that we're designing for, where those cross sections came from. And then lastly, you can see our notes here. You can see the soil type that we changed to compacted gravel. You can see our Allen block specifications, our water specifications, water management specifications, all of that right here drawn in there, and you can easily export it out into your own, basically your own submittal packages as well. Now, one thing to note is if you're looking at this wall and these colors don't look good to you, or you need to change a line type for the grid, anything like that, what you can actually do is you can drop into AB walls again, and you can actually come to File, AB walls options, and you can go to DXF configure. And basically what that allows you to do is change the color of any of the lines that are inside of that export. And if you know the name of it in AutoCAD, you can also change the line type as well. So that's where you would do this. But we can go ahead and click Hide. The last tab inside of the AB Walls options I'll quickly go over is how to autosave, just so that you don't lose any information on accident. The last thing we want is for your file to crash and then you to lose all the work that you completed. So another export that we also have inside of AB Walls is Teresa. So like I mentioned before, especially with seismic, global stability can oftentimes be a big driving force to the wall as well. And I mentioned it, but our software does not run a global stability analysis. We run an internal compound stability analysis, but that's slightly different. So where internal compound stability takes slip arcs from the earth above the wall and runs them into the wall, global stability takes those slip arcs going from the earth above the wall to the earth below the wall. And on sites where you've got slopes above and you've got slopes below, or you're in a seismic area or an area with very poor soils. All of those say that maybe or potentially you should design your wall based on a global stability analysis. And luckily, we have a great export into a global stability software that we use here at Allenblock called RISA Plus. So I'm going to quickly show you that. RISA Plus is not an Allenblock software, but if you guys do need global stability analysis for your wall, you can actually call in or email in at engineering@allenblock with your AB Walls file that you designed, and we can actually run a preliminary on the global stability for you guys as well. But jumping into how to bring that into RISA, you go ahead and come to this DXF RISA 3D export option. You'll want to go ahead and click on Export RISA. You'll go ahead and choose your section that you want to design in RISA. And then you go ahead and click Export. Now, Export brings you to this page where we can go ahead and save it as a file name. We're just going to call ours RISA example test 3. We go ahead and click Save. Click OK. And then we can go open RISA. Oops, gotta input the key. Okay. So I can come into RISA. Like I said, RISA is a global stability analysis software. I would come here and click to start a new document or create a new project in AB Walls. I go ahead and click that. And then you can see we've got our data information. Now, our main goal with inputting or having this export to RISA from AB Walls is that we don't want you to have to do any of the work inside of RISA. If you guys purchase the software, we want it to be very smooth and simple for you to bring in. So all you have to do is click this colorful button here, this import a file created by MSCW or Reslope. You can also do AB Walls as well. We click that. We go ahead and keep our X value of toe at 0 and our Y value of toe at 0 and click OK. Now when we do that, it's going to ask us which one we want to use, and we're going to go ahead and choose our RISA example test 3, the one we just created. So we go ahead and click on that, go ahead and click open, and it inputs all of our data. So all we have to do is click input data, click return, and that's going to kind of run it. And then we're just going to go straight into define search domain for global stability. So you can see we want to change our X3. We're going to move that. So you can see here, we're going to take slip arcs that happen in between from any of these nodes to any of these nodes down here. We'll go ahead and click OK once our nodes are set. And then we click Run. Run is going to do all those calculations, and it'll show us our worst case slip arc. Now, this worst case slip arc right here, you can see its minimum factor of safety is 1.54. That is above our minimum factor of safety, so we are good on this design in terms of global stability. Where you'll actually start to notice walls failing under global stability is when you start having, slopes above the wall, slopes below the wall, or poor soils. So that's our export into RISA. What I'm going to do now is go ahead and come out of RISA. And we're going to start talking about the last of our exports. So the last export we're going to talk about is actually our SketchUp export, so our 3D model. And what it does is it exports a 3D Ruby script that can be used with our 3D modeling tool. If you aren't familiar with our 3D modeling tool, it's an extension inside of SketchUp SketchUp is a 3D modeling software. So our extension inside of SketchUp allows you to open up this Ruby script, and it'll create a 3D model of the wall that we just designed inside of AB Walls. So you guys saw what our wall looks like. You can see it looks just like this. When we actually go into our 3D export, we're going to export Ruby script. I'm going to call it wall example 3. And then we can go into SketchUp. SketchUp has a free version called SketchUp Make that if you're going to just play around with and see if it's right for you to purchase, you can download this Make version. And it does run our extension as well. Also, if you're curious and have never seen the 3D modeling tool, we do have webinars on the 3D modeling tool every Friday to learn how to use it and how to get started with it. But once I'm in SketchUp, I'd go ahead and click on our extension that we've downloaded. Click Allen Block 3D Modeling Tool. Go ahead and click the folder button, because that's going to be how we load our script in. We're going to choose our block type. I'm going to stick, we could choose any of our collections. I'm going to stick with our AB collection. And I'm going to stick with our classic. And I'm going to stick with the brown blend as well. But then once I have all of those filled out, I go ahead and click Open File. We'll choose our wall example 3. And in 2, 3, 4, so like 4.5 seconds, we've got our cross sections. For each of the sections of our wall. But then more importantly, we've got our wall as a 3D model. So you can see it here. If you zoom in, it's fully textured. Each course is a single course in the software as well. But really, it's just a cool way to show a 3D model of your project. Another way that it's really useful is in terms of BIM, or Building Information Modeling. Lots of people are using that to make sure that their models work well with the utilities on their site or other things like that to avoid change orders. Where that would be beneficial is to place your wall in a 3D model of your site, and you can see if the grid layers, which we resemble with these black sheets here, to see if those intersect with any utilities or any of the other constraints on your site. But also, it's an easy way, the 3D modeling tool is an easy way to show your project off and hopefully increase the chance of it getting sold by you, or basically by you designing it. And how you do that, we can really quick, you'll see in just a few minutes, we'll be able to make our wall very professional looking. So you can see I just made a rectangle there. I'm going to add grass to the rectangle. I'm going to click our Kits button, and that'll actually bring up our website. Our website is going to allow us to download a 3D model of a patio package that we have pre-designed. It's got to load. I'm going to go ahead and click download 2017 model. You can see it downloaded right at the bottom of our browser here. All I have to do is drag that straight into our wall here. I'm going to play around with this a bit just to make it look right. Oops. Now, what we can also do, if we want to add something that is not an Allen Block product, we can click this star button, And the star button is going to be how we add a favorite. So these are elements that have been created by other people that use SketchUp, and we can download them for free and put them in our model. I'm going to go ahead and put in a flower onto our wall. So once our page is loaded, we'll click download 2017 model. And just like the patio package, we're going to drag it into our site. And then you can see we're going to just we're going to go ahead and move. So you can see we just added 5 little flowers there. We can also come into the star and go to trees and add a 3D tree. I like this one here. It's going to load. We're going to download the model again. Drag it straight into our model. And you can see how by just adding a few, we added the grass area, a patio, and the flowers. We make this look like something that's very easy to show to a customer, especially on that residential side, get them feeling for a project. But it also is great for, that building information modeling. You can see how a tree on site might interact with the wall, or if you'll be able to have flowers above your wall, anything like that. So that's just a neat feature we've recently added into AB Walls. But that takes us to the end of the advanced features and exports of AB Walls. Does anyone have any questions on this part 2 of advanced features of AB Walls? Okay, I'm not seeing any questions, but I do want to note that if you do have any questions in the future, I will be sending out a follow-up email tomorrow that'll include a recording of one of today's webinars, as well as a recording of part 1 of the advanced features ABU Online for Design Professionals that happened last month. But then also, just go ahead and reply to that email if you think of any questions that you didn't think of right now, and I'd be happy to help answer those. Like I said at the beginning of the presentation as well, if you are interested in one of those one-on-one tutorials of the software, it is eligible for 1 hour of continuing education as well, just like this presentation. But other than that, I think that takes us to the end of our webinar. So I'll go ahead and end the meeting, but I do want to thank you guys for attending today's webinar.